Introduction.
Good morning, teacher.
Good morning, students. Today we learn organic chemistry.
Teacher, what is organic chemistry?
Organic chemistry is the branch of chemistry that involves the study of carbon and hydrogen containing compounds.
Teacher, how the carbon-carbon atoms are attached?
The carbon-carbon atoms are attached by single bond, double bond or triple bond, and the functional group present on the organic compound decides its chemical nature.
Teacher, what is functional group?
It is a group of atoms in an organic compound responsible for the chemical reactions of that compound. In this lesson, you will learn organic chemistry and some basic principles. Objectives. At the end of this lesson, you will be able to define tetravalency of carbon, describe formation of pi bond, represent organic compound through complete, condensed and bond line structural formulas, represent organic compound in 3D, classify organic compound, describe nomenclature of organic compound. Tetravalence of carbon, shapes of organic compounds. Organic chemistry is the study of hydrocarbons and other compounds regarded as derivatives of hydrocarbons. Some organic compounds may also contain elements like nitrogen, oxygen, sulfur, phosphorus, halogen, etc. besides carbon and hydrogen. The shapes of carbon compounds. A carbon atom has 4 electrons in its outermost shell. So, it needs 4 more electrons to complete its octet. A carbon atom can complete its octet only by sharing its valence electrons with other atoms. As a result, carbon atom forms 4 covalent bonds by sharing valence electrons with other atoms. This is known as tetravalency of carbon. For example, methane, ethene, ethine. Carbon can participate in hybridization and form sp, sp2, sp3 hybrid orbitals. Hybridization also affects the bond length and bond enthalpy in organic compounds. The sp hybrid orbital has more s character and hence it is closer to nucleus and forms stronger bond than sp3 orbital. The sp2 hybrid orbital is an intermediate orbital between sp and sp3. Some characteristic features of pi bonds. Pi bond is formed by the overlapping of p orbitals on adjacent atoms. The p orbitals should be parallel to each other and both perpendicular to the plane of the molecule. Pi bond inhibits the free rotation of carbon-carbon double bond. Pi bond provides the electron charge cloud in the molecules which have multiple bonds. Structural representations of organic compounds. Complete, condensed and bond line structural formulas. The structure of organic compounds can be represented by Lewis or dot structure, dash structure, condensed structure, and bond line structures. The Lewis or dot structures can be simplified by using dash. Single dash represents single bond. For example, propane. Double dash represents double bond. For example, propene. Triple dash represents triple bond. For example, propyne. These structural representations are called complete structural formulas. Structural representations of organic compounds. In the condensed structural formula, each carbon atom is written separately and following each carbon atom, other atoms are listed that are bonded to that carbon atom. For example, complete structural formula. Its condensed structural formula can be written as bond line structures. In this, carbon and hydrogen atom are not shown, but only the bonds between the carbon-carbon atoms are shown in zigzag fashion. The atoms other than carbon and hydrogen are shown in the structure, and the terminals denote methyl group. For example, butyl chloride, propene, cyclohexane, diethyl ether, dimethylamine. Three-dimensional representation of organic molecules. Three-dimensional structures of organic molecule on paper can be represented by using solid and dashed wedge formula. The solid wedge represents a bond projecting from the paper towards the observer. The dashed wedge represents a bond away from observer. A simple line represents a bond that lies in the plane of